Hello students, this is your professor Dr. Sharma. In physics 1102, we are discussing about the electrostatic force. We know that the similar charges repel to each other and the opposite charges attract to each other. Today we are going to discuss about how these simple mechanisms, simple characteristics of the charges is utilized in order to design the electronic ink. Let me go back in around 100 AD when the first paper was invented in China. Before that, people used to write in the different clothes and expensive plates, metal plates like copper or some expensive things. And the education and the books are not, the writing is not accessible for the general public. Only rich people were able to educate themselves. But the way the paper was invented around 100 AD, that changed the way of our writings, readings, and the educations, the percentage of literacy around the world. Now we are in the digital world and the electronic world. So we have the electronic ink. So how electronic ink work is quite fascinating. So basically, two companies here at United States, Xerox and E-Ink in Massachusetts, they are competing to each other to develop the inexpensive, reliable, that can produce a lot of colors, graphics, and many other things using the electronic ink. And basically, the importance of electronic ink is it will save the paper. You know, saving the paper means saving the trees. Saving the trees means saving the environment. So a lot in this technology in stack. So the principle for the electronic ink is very simple. I told you that. So electronic ink technology consists of the millions of these small capsules. We call the microcapsules. And these capsules are microcapsule because their diameter is comparable with the diameter of the here. So let's say we have the millions of microcapsules here, okay, which is filled with the dark ink, okay, dark ink. We can fill with the dark ink here. And within these microcapsules, what we do is we put the beads. These are the beads. White bead, we can see this is the white bead. And these white beads are slightly negatively charged. Why we put these white beads as an, why we charge negatively? We'll discuss about this. And these microcapsules are placed between the two layers. We can say the bottom layers and the upper layers, or the top layer and the bottom layer. You sandwich between these two layers. And in bottom layer, what you do is you apply the charges. Means you charge the bottom layer at some point here, for example, here. Then, suppose you charge the bottom layer with the positively charged or negatively charged. You can say, let's say, negative charge are sent to the bottom layer. And in bottom layer, you can see here that these beads are negatively charged. You see here, negatively charged. And negative charge is coming from the bottom. Then negative charge and negative charge repel to each other. And these white beads will go on the top layer. This is the screen. Actually, the top layer is the screen. When the viewers see the graphics or letters on the screen, they will see here what is happening here. These white beads now reaches up, and then the viewer sees the white light, means the white region in this top layer. Then when the positively charged are supplied from here, means the bottom layer is charged with positive charges. Look at here, positive charges, right? So positive charges here. And positive charge from the bottom layer and the negative charge on the white beads. they attract to each other, and these white bits are drawn near to these positive charges, and they replace the dark ink to the upper side. Means dark ink reaches to the top layer now. And when viewer sees the top layer, viewer sees the dark region. So inside the computer chips provide the instructions which charge are need to be supplied to the base layer, bottom layer, whether positive or negative, depending on the what kind of letters and graphics you're gonna produce. And you will have the patterns of the white, right, and the dark regions, white and the dark regions. And these patterns of the white and the dark regions are utilized to make the letters, to design the letters and the graphics we want to see. This is the simple principle of the how charge behaves can be utilized here in the electronic ink technology. So electronic ink technology has the potentiality to revolutionize the way we read in our education system, because just like in the computer screens, we can change the symbols instantly displaying on the LCD screen. Here you have the ability to change the colors, to change the letters and the graphics almost instantly. So it can save a lot of papers. And when you read in the electronic, in the by using the electronic, if you read the letters or the symbols or anything or books using the electronic ink, that is comparable to the physical paper, like a newspaper. When you see the newspaper, physical newspaper, it's very good, right? Light is not so reflective, light is not coming, that can destroy your visions and other things. Just like in LCD, you cannot read the LCD putting the LCD in front of the uh, sunlight. So a lot of lights are coming there, and a lot of optical phenomena happens there. But in electronic ink, the way we printed the materials using electronic ink is comparable with the paper. Still, we save the paper, but instantly we change the graphics and letters. It has a huge potentiality. Basically, two companies, E-Ink in Massachusetts and the Xerox in California, they are competing to each other to make a reliable and cheap, inexpensive, and technologically uh, human-friendly, means the cost-effective electronic ink technology. Let's see in days to come, we will be able to see this technology in an expensive way. So one way we already